Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels.
So welcome back to another lesson in the Ultimate CCNA Prep course, where we are prepping you to take your CCNA exam so you can increase your income, right? And that income can rather be in your job. Maybe you want to go to the IT department at your current job or just get an IT job. Or you want to sell your skills on places like Upwork, Fiverr, or just creating a business out of it to where you're doing something like contract work or something just for yourself, right? So we're actually in the last lesson of the CCNA exam topics, last section, not lesson, let me correct myself, section, which is 6. Section 6 is all about automation and programmability, right? So today in this lesson, we're going to be discussing 6.5 and 6.7. So we're going to talk about REST-based APIs, because we already talked a little bit about APIs, but specifically today, we're going to talk about REST-based. And then we're going to do a little bit of JSON. We're going to learn how to interpret JSON, okay? So let's get into it. All right, so what is a REST-based API, right? So we already know that. Let me get this out my way, Sorry, you guys. I don't know why I just let this sit here. Anyway, so we already know that an API is an application programming interface, right? We know that. And it's a set of rules that allows one program or software to talk to another program or software, right? So we create this API on a server, and that server is going to speak to the client, and the client can speak to the server through this API, this programming interface, right? So REST, R-E-S-T, determines how a specific API, what it looks like, right? How it behaves. Now, REST, as you can see right here, stands for Representational State Transfer. Right? Representational state transfer. That's what REST stands for, right? And it's just a set of rules that we use, most likely developers, but as you are in network engineering, you're kind of like halfway a developer, right? So it's a set of rules that developers follow when we create an API, right? And specifically when we want to create a REST API. And one of those rules is just saying that we're going to use HTTP requests to access and use data, right? Use HTTP to request and access, access and use data, right? So when you think of it like this. You want to go, let's say you are on YouTube, right? And you're looking for Harry Potter movies. Let's say you're looking for Batman, right? Looking for Batman, and you put into the search and you type in Batman, right? In the search field, you press enter, and all these Batman videos, Batman related videos are going to pop up. That is exactly how the REST-based API works. It's a similar way, right? So we're going to search for something, right? And we're going to get a list of results back, and from what we're requesting, we're going to choose which one we actually want to use based off what we're trying to do, right? So that's essentially a REST-based API, right? We have these rules that we want to get a piece of data from, and this data is called a resource, right? And that resource is going to be linked to a specific URL, right? That URL is called a request, right? And like an HTTP request, right? We're going to request some data, and when the data is sent back to us, it's going to be called a response, right? So request and response, okay? That's how that works. If you look at here, the nice little image, look at here, we have the client. The client's going to say, hey, I want to get some information, right, through an API. The API is going to talk to the server. Server's going to say, well, this is the client is, well, the API is going to say, this is what the client is requesting. And the server is going to send a response back to the client on what you're requesting. Again, think of it as a simple YouTube search. I'm looking for Batman videos, right? I'm just saying Batman, and it's going to pop up with the most suggested or recommended Batman videos for me to watch, right? I can get more specific on what type of Batman, funny Batman, the Batman movies, Batman cartoons, classic Batman. Like I can get more detail, but it's going to send me information, right? It's going to give me a response, right? A response. Okay. That's all that is to it. Okay. Now, in order for an API to actually be considered a REST-based API, it has to follow these 6 rules. Okay, let's go through them. So we have, hold on, this just pops up. Okay, so we have client server. That's one rule. I'm sorry, this thing is popping up. I don't know. Okay, go back. So we have client server. That's rule number 1. So we have a client who requests, who's going to request for resources, and then we have a server who has the resources. Okay, so if you look at it, just simple. We have our client, have a server, and our client is going to say, hey, I want something, and our server has it and is going to send it back and say, here you go, here's your response. Okay, that is client server. That's the first rule. Second rule is, so we did client server. Second rule is stateless. Stateless, it basically says what kind of commands that can be offered between the client and the server. So what stateless means is you're going to have to repeat the request in full if you want it. So for an example, let's say I am requesting to know the status of the interface, right? Status interface is G0/0, right? So the server is going to respond and say the status is up, right? Now, I'm going to have to go back and request, I'm going to have to request the protocol. I'm going to have protocol on interface G0/0, and it's going to give me the protocol. That's stateless, right? If it was stateful, I can say, give me the status of G0/0, and it's going to say, it's going to give me a response as up. And then I can say, what protocol is it running? What protocol is on there, right? What's the protocol? And stateful, the server will say, oh, well, we have OSPF. But stateless means that I have to request and say, on G0/0, what protocol is running? I can't just say what protocol is running, even though the last request was what's on G0/0, right? You have to repeat it every time you want a response, right? The response don't know what you said previously. The response only knows what you're saying right now. You're saying what protocol is running. Protocol is running on what? I don't know what you're talking about. Even though the previous request was G0/0, this now request is brand new. We're not talking about what you asked me before, right? Or what the future you're going to ask me. We're talking about right now, what do you want? You have to be specific. That is stateless, right? You have to repeat it in full every time. What is the status of G0/0? Up. What is the protocol running on G0/0? OSPF, right? What is the IP address on G0/0? Right? You have to repeat what you want. You can't just think that it's going to automatically know what you said the previous statement. Okay, that's stateless, right? So then we talk about cacheable, right? So basically it's something that things are, do you want them to change or you don't want them to change? Do you want them to stay in the cache or do you want them to be deleted, right? And that's so we can, we won't have to resubmit the same request, right? So if we know that, let me see. Oh, here's cache, here's right here. Okay, cache will avoid full trip to server and allow less server work. So if we're saying, let me give you an example. Attempt to avoid resubmitting the same information. If I'm asking what's the status of G0/0, interface G0/0, and the server comes back and say it is up, right? I'm asking, it gives me a response, right? It can possibly cache that information. So maybe in a few hours, I want to say like, well, I did some changes. We reset the router. We powered it off, powered it back on. What's the status of G0/0? Now, the response, the request won't make a full trip to the server because that information is cached. So it's going to come back to the client in the middle and be like, oh, I already know it's up, right? And you kind of got to be a little worried with that because sometimes that information could be stale, right? So you probably will only want that information or that cached information to be good within a few hours, right? Maybe not days or weeks or months, right? Maybe days, but not weeks or months, because again, it can get a little convoluted, right? But that's what cacheable is, right? It is basically just attempting to hold information that won't necessarily change, so it doesn't, the server doesn't have to work and give you that response over and over and over again. So maybe the interface is not a good example. I'm going to say, what's the host name of the router GA0296? Right? What's the host name of it? The host name is GA46. Right? That won't change, right? Unless we're actually going to change it. Why would we change it, right? Why are we changing the host names, over and over again? Like, this is the host name, right? We're going to keep that host name for probably as long as we have this network running, right? As long as the site name is in Georgia and the router that we're using is a 1946. I don't know if that's not a real router, but I'm just making up stuff at this point, right? That's something that can stay in the cache because the host name is not going to change, right? The interface will change, so I'm not going to say that could be in the cache because something can happen, right? Where the server's going to have to recalculate and be like, okay, well, it was down, but it's back up. So it's up, but it was down, okay? So if anything, that would be cache. Would be a better example would be like the host name, right? What is the host name of this router? This is the host name. We'll keep it in this cache because again, that stuff is not really going to change. Okay, so that's cache. Uniform interface. Oh, one moment. I'm sorry, you guys. I just got this. All right, delayed gratification. Okay, anyway, so uniform interface. So uniform interface is basically saying that there's a uniform way of interacting with a given server, right? Or type of application. So if you look down here, right, this is an example I was able to find of uniform interface. So no matter what we're using, whether we're using a phone, tablet, computer, laptop, or desktop, we're using SSH or a GUI, we're on this client, that client, it doesn't matter. We are going to use a uniform interface. We're going to use the same interface for all interactions. Regardless of what I'm using, okay? Regardless of, again, if I'm using a different type of client. There's a uniform interface that's going to give, my API is going to talk through and give me information, okay? Now, uniform interface, it does have some like subcategories to it. I believe it's 4 of them. Something like identification, manipulation, representation, something in that sort, which when you go down in the book, it may or may not talk about that, but that's something that they may mention in the CCNA. Definitely make sure you take note on that. However, as long as you know that uniform interface is basically the keep it simple, right? We're going to make sure that we use the same interface for all interactions, servers on the node, right? That's uniform interface. We just want to keep it simple, right? So we talked about that. Now, layered. Layered means that it could be multiple layers that we're going to use as we expand this interface, right? Because we're going to expand it. So there's multiple layers to it, and it doesn't matter what's in the middle. The client and the server can still give the immediate response, right? The client can still send immediate request, and the server is still going to give you response. Right? So the request between the client and the server, they don't really need to know if they're communicating with the actual server. They just need to know I'm getting this information, right? So this is a great example here, proxy, right? So proxies can be useful when we're like load balancing, right? And security checks. That's usually we will have some type of proxy in the middle of our client and server ordeal, right? So it's good for like load balancing, security, all that stuff. Now, a proxy kind of acts like a server in a sense, right? So when the client is and the client initially sends the request, right, the proxy is going to get it. And the proxy is going to act like it's going to relay the message to the server. And the server is going to obviously relay the message to the proxy, who's going to relay the message to the client. Okay, so looking at here, we have our client, right? Our client's going to send a request. Obviously, it's going to go to the proxy. The proxy is going to say, it says, even though there's a proxy, the contract between the client and the server are, the same. So the proxy is going to get that request. Proxy is going to say, oh, you want a request? This is what they're asking. The server will say, okay, well, here's the response, and the proxy is going to send it to the client. Okay, that's basically layered, meaning that you can have multiple layers, and the client and server is still going to communicate, right? It's still going to translate them HTTP requests, just in another protocol, right? And it's going to basically package up that request, translate into a response, and send it back as an HTTP, right? The client won't know the difference. The server won't know the difference. It's just the proxy doing the work in the middle, right? So the client can like simply treat this gateway or this proxy as a regular server, right? And I mean, an example in networking, it would be a gateway or a gateway or a router, right? We use this gateway as a system to like download FTP server. So this can be like our gateway, right? Which is a router, same difference. And this is our server, and this is our client. This is us as at a computer, and this is our server, right? So when we want to send a request, right, to get some information, our data is going to flow to this proxy, aka the gateway, aka the router, and the router is going to say, okay, well, you can get through. Let me send you over to the server. The server is going to say, okay, this is what you want. Let me give it to you, right? It's going to be an HTTP, but it's going to go in a data packet to this gateway, and the gateway is going to send it back to the client in the form of HTTP. Okay, that's layered, right? That's what layer is saying. There can be layers, right? Maybe there's another proxy, and then it's to the server, right? Again, it's multiple layers because we want to expand this interface. And then last one, code on demand, which is actually optional. It's not a required rule to become for an API to become a REST API, but it is there. It's an optional feature. And servers can basically provide this code to the client, right, to execute, right? And basically this happens in like an HTML field. I believe it's like in the HTML script field, something in that sort. We'll kind of go over maybe HTML later on, possibly. Maybe it may be helpful if you guys want to do it. It depends on how many requests I get. Then I will probably come out with an HTML, like either mini course or just addition to this course. I'm not sure yet. We'll see. But anyway, it's a code on demand. It's an optional feature. And the HTML script tag basically has this code for the client. So when this HTML document that has this tag is loaded, the browser, the web browser automatically fetches this type of code, whether it's from like JavaScript or something in that sort, from the server and executes it locally, right? So it's code on demand. I wasn't able to find an image on code on demand, but just know that it's a specific code in this HTML document that the browser will automatically fetch for you, and it will execute on your end, right? And that's all that really does. Again, it is optional, but just know that is exactly what it sounds like, code on demand. You can get a JavaScript code in this HTML document to run on your computer, right? So we talked about that. So those are the 6 rules, one being optional, which is this one, for an API to be considered a REST API, okay? These are definitely notes you want to take down, okay? Because they will ask you, what are some rules that make up a REST API, a REST-based API, and at least you know the 6. Then the combinations of it, you may only have to choose 3, but the combinations of it, you want to at least make sure they're one of these 6. Okay. All right, let's move it along. Now, going deeper into RESTful architecture, right? Because we want to better understand it, we have to go in onto CRUD, right? CRUD, right? CRUD is a cycle for keeping records current and permanent, right? And when we're talking about RESTful APIs, CRUD is the standardized use of HTTP action verbs, right? So HTTP action verbs, we're going to create, we're going to read, update, and delete, okay? So how do we create it? We're going to either post, that's how we create something. We say post, right? Or HTTP, the action is post. If we want to read something, the HTTP action is get. Okay, and if we wanted to update something, the HTTP HTTP action verb is put. Or sometimes you can say, well, it's put and you can say patch, right? Put something or patch something. And then of course, delete, right? The HTTP verb is going to delete it, okay? So with HTTP, right, with these requests, we're either going to create a request, we're going to post something, we're going to read a request, right? We want to get something, right? Let me get this. I'm going to get youtube.com, okay? Let me update something. I'm going to use post or patch, okay? And delete is delete, right? I don't want it. So I got this image because it actually gives you a more visual aspect of actually get and post and put. So we have our URI, right? Our API is in there. And our URI, we're talking about employees. So our verb, we want to get. What do we want to get? We want to get a list of employees. So this is what this URI is saying. It's saying employees, and we're using the get verb, right? We're going to use the get method, and it's going to, okay, let me give you your employees, a list of employees in the company, a list of interfaces, a list of active devices, a list of switches, whatever, you're getting a list of something. Then we have another URI, right? API, employees, and maybe this URI is one. I want to get it, right? So what it's going to do is it's going to get employees with an ID that equals one. Maybe one is in their ID, right? In their identification number, or one is what their identification number, employee ID starts with, or whatever one is specified, and it's all proprietary and specific to your company, right? So again, maybe I want to get all the interfaces that are down, get all the interfaces that are attached to, that are running OSPF. I don't know, right? You want to get something. Then another URI that you're going to put in the field, another API is employees, but you want to post, right? This time you want to create. Okay, so what do you want to create? Create a new employee. Okay, so someone just got hired on, you want to post, right? You want to create this new employee a profile. Okay, maybe you want to create another interface. Maybe you want to create, I don't know, so many things you can create, right? But that's what post is for. Then again, let's just say we have our URI with our API, employees, and it's another one, but we're going to do put now, right? So put is what? Update. Okay, so what do we want to do? We want to update employees with ID number one. Okay, so we can get employees one, which is get employees with ID one, or we can put with employees one, which is update employees with the ID of one. Okay, we can get employees, which is a list of employees, or we can post employees, which is create a new employee. Okay, these are our HTTP action verbs, right? That we're going to use with our APIs to get request information through HTTP, and we're going to request it, and we're going to get a response via HTTP as well. Okay, this is very, very important that you understand CRUD and understand the post, get, put, patch, delete. Okay, and what it do. Well, if I decide to post something, what is that? Right, I'm creating it. If I decide to get something, when you get it, what do? You're going to read it, right? If I want to put Or patch, what does that sound like? Sounds like an update, because I'm putting this in place or I'm patching this up. And then delete is delete. I mean, you can't get delete wrong. Okay, so get, put, post, get, put, patch, delete, right? It's in the CRUD, right? CRUD. CRUD is create, read, update, delete. Okay, standardized use of HTTP action verbs. All right, this is something you definitely want to make sure that you're note taking. You will talk about this in the chapter. I don't know, I believe it's chapter 18 or 19, or maybe even both. I actually didn't look at the chapters today. Sorry, you guys. But in the book, definitely go to chapter 18, chapter 19, or you can just copy and paste in the spine the topic that we're talking about, the little fine magnifying glass, and it'll pop up everywhere in the book where it has this information. And you just go through it from there. Okay. So before we even stop, right, because we talked about RESTful APIs, this is just the basic understanding of it. You may get a little more in depth in the book, because the Cisco book will definitely give you a lot more. However, this is a good enough for you to get your head wrapped around what we are talking about today, right? So you're not totally lost, okay? Now, before we even stop this lesson, I want to go into JSON, right? Encoded data, we want to learn how to interpret it, right? So JSON is the abbreviation for JavaScript object notation, right? So it's JavaScript object notation. Y'all know I don't know how to spell notation, okay? Let me get that out. Notation. Okay, notation. That's what JSON is. And it's basically like a lightweight data that's interchanged like this type of format that's user-friendly, right? So like this lightweight format that's easy to read by not only us, but also the computers, right? So with JSON, you can kind of easily guess what they're talking about, what's going on in the file, without having to be like, oh, I am, I'm proficient in JSON and JavaScript, so I know exactly what this means and that means something else. No, it's kind of like plain text, almost like how Python is kind of like plain text. This is JSON. It's very easy. So this is kind of what JSON will look like, right? So it'll come back, it'll have a name, right? Jane Doe, right? Jane Doe is a name, right? That's easy to read. Salary, right? 9,000, right? Skills, the skills is Raspberry Pi, machine learning, web development. Those are some good skills that Jane has, actually. And then email, right? Projects, what have she done or what project she's working on? Data Python mining, Python data science. Those are some good skills Jane has. But nonetheless, this is what JSON data looks like, right? Pretty simple. The only big things you would have to pay attention to is maybe this right here. That's like a bracket, one of those brackets. As you can see, it looks like squiggly. I'm bad at that. Squiggly, right? One of those. And that basically means a object, right? AKA a dictionary. How you spell dictionary? Right? This is what this wiggly line means. It means a dictionary. So we have the opening dictionary and the closing dictionary, right? Closing dictionary. And this is what's in our dictionary: our name, salary, skills, email, projects, okay? Another thing you may want to pay attention to is this guy, right? This bracket, simple. And I'm looking at my keyboard, they're on the same keys, right? These two, this is the top one, so you have to press like shift to use that. Then we have the bottom one, which is automatic, okay? This means a array, right? This is called an array. And it means a list, right? Array, list, object is a dictionary. That's kind of how I look at it. So an array with the list, as you can see here, we have an array, And it's a list of what? Skills. So we have Raspberry Pi, machine learning, and web development. Close the list. Now we're going to open up another list, and she has projects on her belt. She has Python data mining, Python data science, and then close the list. Okay, that's probably really the only two things that you probably have to decode. Outside of that, it's pretty self-explanatory what's happening in this data, right? We kind of know, like, oh, we're getting Jane Doe's information, right? And the information is as follows: name, salary, skills, email, projects. Okay, so the client is going to request information, right, in the form of JSON data, right? And it's going to do one of these methods. Is it going to get, right, post, put, or delete, right? And so as it follows through the API is going to send it to the server, right, as an HTTP request, right? And the server to send a response, right, as an HTTP response, right, back in a JSON data to your client. And this is what it's going to show up. It's going to show up something that looks like this. Now it can say something as simple as interface G0/0, status up, protocol up, OSPF, right? These are what's connected to this interface. These are the IP addresses on this interface. The whole bunch of other stuff, I don't know, but whatever has to deal with the interface or router, what's going on with this router or this switch or this networking device, whatever you can think of, because we're still in network engineering. Yes, it seems like we're now turning into software developers, but this is the information that we're going to use as we automate our networks, right? Because automation, programmability is the new wave. Okay, and if you don't know this, then no one wants you to work for them. And what are we all about? We're all about making that money. So if we want to make that money, we need to do things that are trending, that are the future. And JSON, Python, JavaScript, these dev tools, these developer tools are what's going to get us paid. Okay, so again, let me erase this here. Erase. Chapter 18, 19, one or the two, I don't know, I don't remember. It's in the Cisco book. Make sure that you read the Cisco book, take notes, do your flashcards. Tomorrow is our last lesson, right? It's our last lesson in this automation section, and also our last lesson in as far as the CCNA exam topics are concerned, right? I may come out with a couple more lessons that probably deals with HTML and CSS. Definitely, I'll come out with a lesson. We'll probably do a live, or it'll probably be like pre-recorded, who knows, on LinkedIn. How are we going to get our LinkedIn profiles together so we can actually get a job, right? I want you guys to definitely set up a one-on-one. I'll let you know when one-on-ones are open. I'll be reaching out to everyone individually to see where you guys are at. And so we can see how we can make sure that you increase your income, because that's all that this is about, right? Whether you actually take this CCNA or not, the goal is to still increase your income by tech. Right? Maybe it's not by tech. Maybe I can get you into a job that, something that you feel is more your speed. I don't know, but I want to have this one-on-one with you so we can ensure that we get you more money in your pocket, period. All right. So before we close out, obviously we do have a lab. Okay. So I just wanted to show you guys the Trello desktop application. This is where all of our exam prep notes will be stored. So if you have access to the exam prep notes or you're in the boot camp, this is our Trello workspace that we will come to and collaborate our knowledge and questions, comments, concerns. You will still use the Discord for your primary communication, but this is where all the material is housed. And I just want to give you just a quick little run through. Now, right now, we are doing the CCNA/Net Plus learning. So as I do the lives or I do recorded videos, I will post them here. And as you can see, we're going to start off in this board, which is called the CCNA/Net Plus. You'll start here for all notes. Now you definitely can click on this, right? And it will give you some information like the Google Drive. That's where everything is housed in our drive if you can't find anything. This is also where I will possibly tag you to say, here, start on this board and work your way through. These right here are the exam topics. You can click on it and see it's an attachment as well as a link. All right, click out of it. You can click into this card, which is the Computer Networking 101 ebook. It's just the ebook with the computer networking all comprised in it. Not as deep as the CCNA, but it talks about it in general. So you can get a general aspect of how computer networking works. Basically, how computers talk to each other, right? You get this ebook for free. It is $25 on the website, but since you signed up for the boot camp or for the exam prep notes, you get this ebook for free here. We also have the CCNA Quizlet. So these are our flashcards or play little games with the terms. So it can help you retain this information as you go through these modules. Each module, right, as you can see, has its own list. So we have network fundamentals, network access, IP activity, moving on. Each exam topic is listed in its own video. As you can see, the lesson 1.2, lesson 1.3, 1.6 and 7, and they're all here laid out for you. And then at the end of the section, such as section 1, you will have an exam, a pop quiz, just a test exam, just to test your knowledge, see if you retain some information. If you haven't, it would be best for you to go back and review the things that confused you or you just wasn't able to retain, possibly even going back to the Quizlet. But if you are confused and the videos are not helping you, the resources are not helping you, please utilize Discord and we'll be glad to get you caught up to speed.